Greetings, welcome to Game U. I'm instructor Robert Santiago, studio lead of Hypostatic Studios and graduate of the Rochester Institute of Technology. I'm here to help you learn how to use Unity for game development. Unity is a 3D game engine that utilizes the C# coding language for all of its gameplay coding. C# is an object-oriented programming language, which means one coding script can be used for multiple game objects in our games. Today we will be learning how to create a 3D platformer game using Unity animations, AI, and C# scripting. First, let's explore some of the basic features of Unity. We can think of our main working area as having a circle of importance. The bottom project panel contains all of the game assets and scripts for our entire game. On the left-hand side, we have the scene hierarchy, which contains all of the different assets and game objects for this specific scene or level of the game. And then on the right, we have the inspector, which contains all of the details and components of one single game object that you select inside of your scene. The viewport is the main area where we can see the results of all of our hard work and play our video game. We can also see the transform cube up at the top right corner of the viewport, which reminds us where our X, Y, and Z axes are. 2D games have X and Y axes, which are left and right, up and down, and 3D games have X, Y, and Z, which adds depth to our 3D game. I've set up a test level here employing all of the basic features of Unity, using free assets from the Unity Asset Store, and I'll show you how I put this scene together so you can create your own game. First, let's take a look at our third-person character controller. You can download this character controller at the Unity Asset Store, which has thousands of free and easy-to-use assets, which can help speed up your production. So by going into the InVector third-person controller, by going to prefabs, we can drag and drop a prefab, which is a preset instance of a game object with all of the assets and script already attached, into our game scene. So when we put a game object into our scene, we'll see that it has a 3D transform of X, Y, and Z axes, and we will be able to move that around by dragging each of the X, Y, and Z arrows around in 3D space. Now, if we look on the right-hand side in the inspector, we could see that we have our transform, which keeps track of all of our position, rotation, and scale, and then all of the scripts and different components that we have attached to our game object. We're going to take a look at all of the different functions of a script, but for now, let's take a look at the rigid body component, which adds physics to our game object, including mass, drag, which is friction, and gravity. We also have a capsule collider, which will track all of the different collisions inside of our game. So anytime that your object bumps into any other object, a collision function will fire inside of your script that enables you to do certain actions, such as take damage or pick up items. So a script is a C# coded asset in your game that allows you to do different things like handle input, which we can see here is being handled by the input manager script. And we can see that the horizontal input of our mouse is being tracked, and different buttons on our keyboard are being tracked to complete different actions. So by going up to the top left and going to the edit menu, we can go to the project settings of our game and then go to the input manager and set all of our different actions to different functions on our keyboard and mouse. So we can see the fire button is currently attached to the left control button on our keyboard and the left mouse button on our mouse. So let's take a look at how to set up an enemy AI using a script inside of our game. We have here a pre-made golem asset from the asset store that we've downloaded and imported. And once we drag and drop the golem into our game scene, then we can go down into the inspector for that object, and we can click on Add Component. We are then going to add a nav mesh agent, which is a type of AI agent that can keep track of the pathfinding principles of your character. Once we have a nav mesh agent added to our game object, we are going to want to go to the window up at the top left of the screen and then go to AI and navigation. And the navigation menu is going to help us bake a navigatable mesh into our terrain. By clicking on the object area of the navigation panel, we can click on our terrain that we want to make walkable by our AI. A terrain is any flat surface that is able to be deformed by special Unity tools. And we can see some of the tools here, such as paint terrain, which we can use to lower and higher different areas of the terrain. And we also have paint trees, which will allow you to place different models in mass inside of your scene. And paint details, which will allow you to add foliage and grass, which takes up less resources than full 3D models. So let's go to the object panel of our navigation and then click on terrain, and we'll see that it loads it in as an object that we can then bake a navigation mesh into. So we can see that navigation static is going to make a constant walkable surface on our terrain, and generate off-mesh nav links will generate certain areas of our terrain, such as gaps or rivers or boxes, so that the AI can automatically travel and transport over different complicated areas of the terrain. Next, let's go to the bake section of the navigation menu, and we can see that we have a couple different settings for our nav mesh of our terrain. So we have the agent radius, which is going to set the overall circumference of the nav mesh agent that is going to be traversing the terrain. And then we have the height of the nav mesh. And these settings are going to be used to determine the ability of the nav mesh AI agent to walk up and down complicated areas of the terrain. So we can see here that we could set the max slope that we want the AI to be able to walk up, and also the height of different steps that they were able to step up on top of. We can then click the bake button to bake the terrain as a walkable nav mesh, and then you'll see this blue kind of layer added on top of the terrain, and that means that it is good to go. So now let's take a look at our first script, and we're going to click on our golem, and we are going to add a rigid body, a capsule collider, and an enemy AI script. So if we click on our enemy AI script, a script is made up of a class, which is a kind of a cookie cutter for all of the different functions and data that you want this game object to have. So we're going to make a public nav mesh agent called enemy, which is going to be a variable that can store the nav mesh agent of the golem. We're also going to want to include the using Unity engine.ai parameters up at the top of the screen, which will enable the AI settings of our game. We're also going to want to include an animator, which we'll look at in a second. But the basic steps of setting up our AI is going to be AI animator equals get component, which will get the AI component from the current game object. And then we can also store the player's location by using gameObject.find gameObject with tag. And we're going to want to go and add a player tag to our player so that the code is able to search out the player and then store its location. So we can see here, we just click on the game object, go to tag, and then add the player tag. And then we could go back into our AI code, and all we have to do in order to get the enemy AI to search out our character is store the player's location based on their tag, and then go to enemy.setDestination and set it to the player location's position. And this will set the enemy AI to start chasing the player around our game level. So we can see that the enemy AI will now chase our player. However, we're going to want to set up different animations for this AI. So we're going to want to go to our golem game object and add an animator. So an animator consists of 4 components, which is a controller, which switches between the different animations, an avatar, which contains the rig of the game object, and then different settings such as root motion, which will cause the animations to move the game object or not, and then our update and culling mode, which will affect how the game object is drawn on screen. So if we click always animate, the game object will always be animating even when off the screen. And if we cull the animations, then they will stop once the enemy is off the screen. First, let's create a controller. So we're going to want to go to create animator controller. And this is going to be a grid with different animations included that are going to transition smoothly based on different conditions. So once we have our animator controller, we can choose any animation and then drag and drop the animation into the animation controller, and you'll see that it'll automatically set up the animation to be played as soon as the game is entered. So if we click on the small node connecting the animation states, we will see that right now there is no condition for it to be changed. So to set a condition for animations to be changed, we're going to want to go to parameters and then click this plus button. And there's a couple different ways to set these transitions, but we're going to be using a bool, which is a true false statement. So we can create a bool, for instance, is walking. Okay, so let's add a second animation in here and then create a transition by right-clicking on the first state and then click Make Transition and connect it to the second animation. Once the animation is connected with a transition, we're going to click on the arrow for the transition and see we have some different settings here. So we have has exit time, which is going to make it so that if exit time is clicked, then the animation will have to play for a certain amount of time before it switches over to the next animation. So we're going to disable exit time so that the animation can transition quickly. And then we're going to go down to conditions, and we're going to see that it automatically added in one of our parameters, and we could set the transition to occur when is walking equals true. So now we can go into our game code, and we can see that we can set the transition to be triggered a couple of different ways. So one would be, here we can see that we are calculating the distance between the player and the enemy. And if that distance is within a certain range, then we could go AI animator dot set bool, and then in parentheses to denote a function, and then name the parameter that we had made for the condition called is walking, and then set that to true or false. We could also set this to be triggered by different inputs on the keyboard or the mouse. So if we check out our player script, we can see here that we have if input.getKey, keycode.w, then the animation can be triggered based on this input. So the input class right here is going to take the input state of your entire keyboard and mouse, and by using getKey, we'll be able to check if any of the keys are pressed down on the keyboard currently. And keycode.w will ask the state machine of the keyboard if the W key is currently being pressed. So we can use this to add forces to our character's rigid body, causing movement, or we could cause the animator to trigger certain movements for our characters. This is going to be the basic way that we set up movement and animations for our game. So we could see here that if we click on the golem, if we look at his animation graph for the controller on the bottom right hand of the screen, we will see that it is constantly looping on the idle animation because we haven't yet triggered the parameter for the transition. So as we walk towards the golem, if we go within a certain distance, we are able to see that the animation is going to switch over to the walk animation because that condition has been triggered. So we can now see the walk animation is being triggered, and then once it gets close enough, then it'll switch over to the attack animation, and that will allow us to have movement, enemy AI, and animations all rigged to our coded scripts. So next lesson, we're going to look at collisions and see how we can set up UI like health bars. So you can see that once we hit the golem, our health is lowered. And then we could also add platforming elements and all different types of game items and extra features to our game. But we're going to continue that next lesson. To wrap up, Unity is a complex and powerful game engine with many moving parts. But as you continue to explore the different programs and code the different features you'd like to realize in your game development will become like natural muscle memory, exactly like a second language that you use to interact with the amazing robotic allies that make up Unity. I would like to congratulate you on completing your first lesson with Game U. You've learned a lot already, and I'm sure you will have an amazing journey ahead of you. I look forward to our next lesson, and I wish you all the best on your journey to realizing your digital dreams.